Fostering conceptual learning. How do humans learn concepts, for example, the difference between dogs and cats? By randomly coming across dissimilar examples: Chihuahuas, tabby cats, Great Danes, picture book lions, calico cats, Welsh terriers. Spaced and interleaved exposure characterizes most of humans' normal experience. It's a good way to learn because this type of exposure strengthens the skills of discrimination. The process of noticing particulars: a turtle comes up for air, but a fish doesn't. And of induction, surmising the general rule: fish can breathe in water. Recall the interleaved study of birds in one case and of paintings in another, that helped learners distinguish between bird types or the works of different painters, while at the same time learning to identify underlying commonalities of the examples within a species or an artist's body of work. When asked about their preferences and beliefs, the learners thought that the experience of studying multiple examples of one species of bird before studying examples of another species resulted in better learning. But the interleaved strategy, which was more difficult and felt clunky, produced superior discrimination of differences between types without hindering the ability to learn commonalities within a type. As was true for the baseball player's batting practice, interleaving produced difficulty in retrieving past examples of a particular species, which further solidified the learning of which birds are representative of a particular species. The difficulty produced by interleaving provides a second type of boost to learning. Interleaved practice of related but dissimilar geometric solids requires that you notice similarities and differences in order to select the correct formula for computing the volume. It's thought that this heightened sensitivity to similarities and differences during interleaved practice leads to the encoding of more complex and nuanced representations of the study material, a better understanding of how specimens or types of problems are distinctive and why they call for a different interpretation or solution. Why a northern pike will strike a spoon or a crankbait, say, but a bass will happily powder his nose until you see fit to throw him a grub or a popper. Improving versatility. The retrieval difficulties posed by spacing, interleaving, and variation are overcome by invoking the same mental processes that will be needed later in applying the learning in everyday settings. By mimicking the challenges of practical experience, these learning strategies conform to the admonition to practice like you play, and you'll play like you practice, improving what scientists call transfer of learning, which is the ability to apply what you've learned in new settings. In the Cal Poly batting practice experiment, the act of overcoming the difficulties posed by random types of pitches built a broader vocabulary of mental processes for discerning the nature of the challenge, e.g., what the pitcher is throwing, and selecting among possible responses than did the narrower mental processes sufficient for excelling during massed, non-varied experience. Recall the grade school students who proved more adept at tossing beanbags into 3-foot baskets after having practiced tossing into 2- and 4-foot baskets, compared to the students who only practiced tossing into 3-foot baskets. Recall the increasing difficulty and complexity of the simulation training in jump school or the cockpit simulator of Matt Brown's business jet. Priming the mind for learning. When you're asked to struggle with solving a problem before being shown how to solve it, the subsequent solution is better learned and more durably remembered. When you've bought your fishing boat and are attempting to attach an anchor line, you're far more likely to learn and remember the bowline knot than when you're standing in a city park being shown the bowline by a Boy Scout who thinks you would lead a richer life if you had a handful of knots in your repertoire.